Okay, in this video we're going to take our 5 degree of freedom model and run it and print the expressions for the mass matrix and the forcing vector to the screen. Remember, the mass matrix is the m part of F equals ma, and the forcing vector is the F part of F equals ma. We're going to take those expressions and paste them into a text editor and reformat them into a way that's conducive to entering them into Matlab and working with them in a Matlab code so that we can use F and M to solve for the accelerations of the model, which we need to update the states of the model as we're integrating it forward in time and performing actual forward dynamics simulations of musculoskeletal motion with this model. Okay, so let's go into our 5 degree of freedom code from last time. And I'm going to make one small change before we proceed here. I'm going to go down to my joint moments and change the signs in all of them. So all my positives are going to become negatives, and all my negatives are going to become positive. This is arbitrary. It's not done for any sort of mechanical correctness type purpose. It's just defining the joint moments and the directions that I'm most familiar with and like to work with. This makes all counterclockwise moments at all the joints positive and all clockwise moments at all the joints negative. Again, that's not necessarily mechanically correct by any particular definition. It's just what I'm familiar with and like to work with. And let's save our code there and go and run it in Python again. Give us a little room here and run our model. And I'll output my mass matrix to the screen here in a moment. And my forcing vector in a little bit longer moment. There they are. Now I'm just going to copy those expressions there and go to my text editor, go to a blank page, and paste them in here. And space them out there. Okay, you should be able to do what I'm going to do here in any text editor that has find and replace capabilities. On the Mac here, I really like this program BB Edit. It's a really fast and powerful and versatile text editor, really good for coding applications like this. It's got a registration fee, but if you do download it new, it is free for 30 days, so you should be able to use it free for a little while, and I don't think the registration fee is too expensive either. Okay, so it may not be obvious just from looking at it, but this mass matrix is indeed a matrix. It's a 5 by 5 matrix of terms related to the mass and inertia of the model. And this forcing vector is indeed a vector. It's a 5 by 1 vector of all of the inertial and active forces that are applied to this model. It's formatted in a way that is unique to how PyDy exports expressions like this, and is unfortunately not conducive to using these expressions directly in Matlab. If I were to paste these directly into Matlab and run it, Matlab just wouldn't know what to do with it. It's not in Matlab's format. So we need to reformat them in a way that is conducive to using with in Matlab, and that Matlab can understand and can define as a matrix and as a vector. So first thing we're going to do is delete the front of this matrix here, indicating that it's a matrix. So I'm going to delete matrix and the curved brace that goes with it. Then go on the end and delete the curved brace on the back of it. And same deal here for the forcing vector, delete it on the front, delete it on the back. You can see there's a bunch of square brackets peppered throughout here. They're on the ends, fronts and ends of these expressions, and there's also a bunch throughout the expression that you probably can't see right now. And we don't need those either. So I'm going to erase all my curly, or all my front ones, all my left-facing ones, and all my right-facing ones as well. I could go ahead and do that manually. I could delete these, and then I could scroll through here and look for other ones. Oh, there's one. I'm going to delete it too, yada, yada, yada. That would take forever and it'd be a very time-consuming and error-prone process, so it's better to do it automatically. I'm going to do Command F here to find text, and I'm going to look for a right-facing bracket, and I'm going to replace it with nothing, which just means replace it with nothing, delete it. And that'll delete all my right-facing brackets. I'm going to do the same for all my left-facing brackets. I don't need those either. And now they're all gone. Okay, another change we need to make is you'll notice here that peppered throughout this forcing vector expression, we sometimes see these double stars or double multiplication signs followed by a 2. That nomenclature is how some coding languages and scripting languages indicate raising something to a power of 2 or raising something to some exponent power in general. That's not how Matlab likes it. Matlab likes it like this, with the caret sign indicating raising to the power of 2. And so like we replaced our brackets with nothing, we're going to replace all of our double stars with a caret sign that Matlab understands for exponents. Okay. And you'll also notice here that all of my time-varying quantities, all of my dynamic symbols that I defined in PyDy, have a argument of t entered into them here in this expression, indicating that they are time-varying quantities. And it's like that for the q's, the generalized coordinates. It's like that for the v's, the generalized speeds. If I can find a force here, you'll see it's like that as well for those. Yeah, here's the force, my contact force, which is also a time-varying expression. If I go to the end here and look at my moments, it's also got those as time-varying expressions. That's again just how PyDy indicates to you that these are time-varying expressions. For working with them in Matlab, we don't need to tell Matlab about that, and it won't know what to do with that information. And so we're just going to get rid of those as well. So I'm going to search for any time I have a t in brackets, and again replace it with nothing, just to get rid of it. And they're all gone. Okay, last thing I need to do is actually enter all 25 of these elements into the mass matrix individually into a particular place in that matrix. And same thing here in this forcing vector, I need to isolate all 5 of the equations in that vector and enter them one by one into a specific place in that vector. The easiest way I've come up with to do that is to do another find replace operation, where you can see in this mass matrix, you'll see some commas peppered throughout here. And those are indicating demarcations between the different elements of the matrix. So the first element of the first row is this MA plus MB plus MC here in the mass matrix. The second element of the first row here is 0. The third element is this expression here, all the way up to that comma there, etc., etc., etc. So I could scroll through here, and every time I want to end my line in the Matlab style, I could replace my comma with a semicolon and then do a return. And same thing here at the end of this element, do a semicolon, return. Same thing out here, semicolon, return, etc., etc. That would take me a really long time to do that, even for this fairly simple model here, and it'd be very error prone. I may not necessarily find all of these commas that are followed by spaces here at a glance. So it's easier to, instead of doing it by hand, to have find replace do it for us automatically, where now I just look for every time there's a comma followed by a space, and I replace it with a semicolon, Matlab's indicator that the line has ended and that I don't want to print the line to the screen. And the other neat thing you can do here with find replace is include formatting text here, where if I do a \n, what this is saying in the parlance of text editors is go anywhere that there's a comma followed by a space and replace that text with a semicolon that's followed by a new line, by a full break there. So this will take all of my comma spaces and replace them with semicolons, and then start the new, or start whatever follows that semicolon on a new line. And if I do replace all here, then you will see this broken up into 25 lines for the 25 elements of the matrix instead of one long line. And here 5 lines for the 5 elements of the forcing vector instead of one long line. So really handy argument to use here in this text editor that saves us a lot of time, especially in formatting this mass matrix. Only one it misses is the very last element here, so I'm going to go in manually there and give him a semicolon. And same thing here on the forcing vector, give that one a semicolon. And then last, I just need to give this forcing vector a name and tell it that this first line is the first entry in that vector. And do that for all 5 lines here to fill out my forcing vector. And then same story here for my mass matrix, except for it's a matrix, so it's going to have rows and columns. And there's probably a faster way of doing this part here with Findreplace, but I'm just going to do it manually. It doesn't take all that long with a fairly small model like this. Okay, the way PyDy outputs or formats outputting a matrix to the screen here is the first 5 are my first row, so 1, 2, 3, 4, 5. The next 5 are my second row, 1, 2, 3, 4, 5. Then my third row, 2, 5, fourth, and fifth. And then each one of those has 5 columns, 1, 2, 3, 4, 5, 2, 3, 4, 5, 5. For big models, you get into kind of a Zen-like mode for doing this sort of thing. Okay, so now I have my mass matrix and my forcing vector, and they are ready for me to use in Matlab. So let's go into Matlab and paste those in. And clear everything out. And save my code there. Let's put it in my Matlab files. Let's just name it Knies 70W. Equations of motion, EOM.m. And I run it, and it did nothing because it gave me an error here. It said unrecognized function or variable MA on line 6. So what happened was it was running my code, and it was trying to enter the actual value of the first row of the first column of the mass matrix here. And it got to the very first thing it was trying to do, trying to add up these masses of the segments A, B, and C here, the trunk and the thigh and the shank, and says unrecognized function or variable MA. And that's because it's going to my workspace here, and it's saying there's nothing in there. There is no MA. I don't know what the value of MA is, or MA is undefined. And even if it had that, it would get to MB, it wouldn't have that, and MC, and wouldn't have that. The problem here is that I've got these expressions defined symbolically, but in Matlab I'm going to be working with these things numerically. So I need to move beyond the symbols and have actual numerical values for these parameters in the model here, things like the mass of the segments and the lengths of the segments, and also actual numerical values for the variables of the model, the generalized coordinates, the q's, the generalized speeds, the v's, and also those contact forces and those joint moments. For now, we're just going to assume the contact forces and the joint moments are 0. So I'll go ahead and enter zeros for those. But even with that, I'll run it and still get the same problem here. I still need numerical values for all of my parameters of the model here, and for all of my generalized coordinates and speeds. And so we'll stop there for now and pick up in the next video on defining those model parameters with actual values and picking some values for the generalized coordinates so that we can actually work with this mass matrix and this forcing vector, and then actually solving these equations to compute the accelerations and doing some rudimentary visualizations and calculations with the model.